Hi there, welcome to VCode's 100 Days of Coding Challenge. Today is day 28 and let's see the question number 2. The question is, write a Java program that performs a binary search for a given element in a sorted array of integers. You will be given a sorted array and a target element, and your task is to find and return the index of the target element in an array using binary search. So we need to use here a binary search algorithm to find the target element in an array. So the function description is given, the return type is int, and which is the index, and binary search is the name. Here the parameters are an array and the target element. So the same thing is written here. We also need to remember that we need to return -1 if the element is not found in the array. So the sample input is given, so which is an array and the target element. So this target is present at the index 4. So you can observe why are we doing this algorithms. So we can generally understand just by looking at the array that the position of the target value is at 4 or 5 or anything just by looking. But computers won't understand like that. That's why we are writing these algorithms, so that computer will understand these. So that's why. So let's now find out what is this binary search and how to approach. So I'll take the same example of this array and let's check out. So here what was the target? The target element was 15. So here the target is 15. So let us keep that aside. So now here the first thing we need to do is we need to write the left and right element. So the left element is the leftmost point, which is 0, which is the 0 element. So this is the indexes, and the right index is the rightmost, which is array.length -1. We know that, right? So ARR, okay, so let me write it simple, a.length -1. So in this way we can find the last index. So these both are very important in this algorithm. So we have these. Okay, so the basic idea of binary search algorithm in Java. So this is an algorithm, so it can be used in any language. So in this algorithm, the idea is to not entirely search the array, but to divide the array and only search in one of the part. So the idea is, as it is a sorted, so we need to divide the array. For that we need to find a mid value. So the mid is, so what is the mid index? So let me write the mid is equal to L plus R by 2. So it is simply the sum of left and right indices and divided by 2. So what if we get some 4.5 or 3.5 from this? So we need to consider only the integer part. So in Java it is done automatically. So if we get, so let me take here it is 0 and here it is, so let me write the indexes also here for this array. So 0, 1, 2, 3, 4, 5 and 6. So now, so this is 6. So now what is the mid value for this array? Start at the start, 0 plus 6 by 2 is 3. So the mid value is this. So the arrow points towards the index position of that array. So the mid value is now 3 for this array. So now what is the target value? So now it's the point to check the value at the mid and the target value. So what is the value at the mid? It is 12 and the target value is 15. Is the target value greater than or less than the mid value? So it is definitely greater. So this target value is greater than the mid value. So let me write it as M. That means our target is in the right part of the mid value. So we don't need to consider the left part of this array. So it is of no use for us. So successfully we had eliminated some part of the array without, so we don't need to find it anymore. So now we can find this only in the right part. So this is how this algorithm makes it easy. So now we only need to search in the right part of this array. So now the start is the mid value. So now we need to update the start value. So we need to update the start with mid. So what is the start? So that is this L, right? So this L is updated with the mid value. So now we have to search, so we have to find the mid again to this. So now this mid is gone, and now we have to find the mid again. So here it is 3. So what is 3 plus 6 by 2? So 3 plus 6 by 2 is 9 by 2, which is 4.5. So the integer value is 4. So now this is the mid. So let me write it as M. So now we have to again check if the target element and the mid value, or what is the comparison. The target element and mid value is equal. So successfully we had found the target value. So here what is the index? So as we have found, we have to return the index value of that particular mid. So mid value. So what is the index? It is 4, which is mid itself. So successfully we had found our target element at 4. So this is the algorithm of binary search. So it's basically like we are on a search mission and we need to we have very less time and we need to find the target element. So we are dividing the, so we are reducing the space to search. So here we are removing certain part of array by knowing that we can't find the target element there. So we are just not searching there. So this is the approach, and now let's write this entire thing in code. It may look scary, but it's very easy. So let's write the code now. So I'll declare here a simple array int ARR. Let me write the same array. So let me take the same thing and let me write the target also same. So int target is equal to 15, and now I will write a print statement and call the function binary search of ARR comma target. So now it's time to write the function static int binary search, which takes input parameters of array and target. So now it's time to write the function. Firstly, what we have to do, we have to declare the left. So let me write it as left. So it is 0, and int right is equal to array.length minus 1, which is the last element. So it should be length. So now, okay. So what was the first condition? We need to find the mid value. Int mid is equal to L plus R by 2. So here it is left and right. So now we have written the mid value. So what is the first thing? If mid is equal to target, then we need to return the mid. So mid is nothing but the index, right? So if we had found the target value at the mid, so it will be ARR.mid, ARR of mid. So if we had found our target value at the position mid, then we have to return the mid itself, which is the index. Else, if the target value is greater than the value at the mid, so that means, so the target is greater than the array of mid. That means if so let's suppose the mid is the mid value is 4, that means it's this position, and the target is greater than that. That means we need to update the left value with mid. So now the left value will be so the start value will be updated. So else, so what if the value at the position is, so that is array of mid is greater than the target. That means the value at the mid is greater than the target. So let's say if our target was 7, then we would have checked the left part of the array. So then the right will be updated with mid minus 1. So here we don't need the mid also, we can just write the mid plus 1. So here we don't need to check this one, so we can directly check this. So this was it. And now if none of this was true, we need to return minus 1. So till when this whole thing will be running? So it will be until the left will cross the right. So that is while this left is less than or equal to the right. So until then, this whole thing should run. So there must be some point at which the left will cross the right, right? Until then, we have to do this. And finally, we had got it. So this return minus 1 must be out of this while loop. It is here. Because if none of this, so even after searching the entire array, we didn't find the element, then it will return minus 1. So this, after this entire iteration, so even if we didn't find the value, then we will return minus 1. So this is how we write the code. So now let me run the file javac binary search.java and java binary search. So now you can check, we had got the value 4, which was exactly the output here mentioned. So this is how we perform the binary search, and with practice and more revision, you will also understand it more clearly. So that's it for this video. Do follow the 100 Days of Coding Challenge by VCode. Thank you for watching.